Hello guys, I'm Jonathan. So now I'll be presenting the program that I've built for this image identifier for Blackpink. Okay, so I've been using TensorFlow and Keras, which is a pre-built Python library inside Python, and the strategy, the classification strategy is called data augmentation. So what is data augmentation? So data augmentation is a strategy used to increase the amount of data by using techniques like cropping, padding, flipping, etc. That data augmentation makes the model more robust to slight variations and hence prevents the model from overfitting. Okay, so this part we'll be seeing later from the codes. And here there's one terms they mentioned about is the image data generator, and yes, this is the one. This is the preview software inside TensorFlow that I'm using mainly for the program. Okay, so let's move on to our codes. So as you can see, this is the program that I've coded from scratch. Okay, so firstly, I've imported all the libraries that I need to use. So let's say the TensorFlow, the Matplot library, CV2, the OS, and the NumPy for the image array. And that's all of it. All these are all the subcategories inside the TensorFlow and Keras. So okay, this is the first part. The second part is I actually ran just to test the loading image function and the plot I'm show function, just to make sure that the imported codes are working. So I just simply loaded a picture of Jenny. Okay, as you can see here, the measurement of the picture is not scale yet. So this is the original size of the image. So here I rescale all the dataset by 1 divided by 255. So I rescale the training dataset and the validation dataset, both of them. So and about here is the here's the part where I normalize the pixels of the images that I've put inside the training data folder and the validation data folder. This function, this part is used to normalize the pixels to values for future image processing use. So the train dot flow from directory, and this is the function that I've been using. So as you can see that it is getting from the directory from the training. This is the train dataset, and the validation dataset is getting for the file, the folder validation. Okay. So 400 images belong to 4 classes. 400 images belong to 4 classes. Okay. All right. So here is the one of the main part of the program, which is creating the model architecture. So sequential is the function, is one of the function inside TensorFlow. So it's used to build the model layers by layers. They split out the images into layers by layers into smaller parts for better interpretation. Okay, so basically here is just creating layers, pulling the layer, and flatten it, and then it drop. Okay, just repeating the same progress. Then before the model end, just compile all the models that has been created, and then model fit it into an accurate measurement. Like here mentioned before that it prevents the model from overfitting. This is where this model fit the function text part. Okay, so this is the value of the import is the amount of the training the data. So in the beginning, I've met a problem where my accuracy for my training data is really low. So as you can see now, the validation accuracy here, all here the validation are 0.9 and above. So it means that the accuracy for identifying the images is more than 90%, and that's very high. So before that, I only ran around 20 initially I doing 20 epochs, which only trained the data around 20 times. So the validation accuracy I got is around less than 50%, around 0.3, 0.4 something, and that's really, really low. The image can't be identified, the Blackpink member cannot be identified accurately also. So after that, I've changed it, the epochs, the value of epochs to 100 epochs rank. So it will ran the epochs 100 times. So let me demonstrate to you. So you can see that the epoch is actually running one by one. So of course, it takes a longer time for the data training purpose, and but it has higher accuracy, a way higher accuracy than low epoch. So here is the part where for the validation data. So this validation data is just to identify the classification for my final progress. So as you can see that here that I actually classify into 4 folders, which is a folder named Jenny, Jisoo, Lisa, and Rose. So these are the 4 folders that I created for the classification purposes. So here is the last part, which is the most important part of the program, the main. So I imported the sArray function from NumPy to sort all the images into an array form. So, and this is the classification that I've created an array. So the first one is Jenny, Jisoo, Lisa, and Rose. And for this dir path, the directory path, this is the path where I get my testing images. So all my testing images are located inside this folder testing. So there are total of 12 images with three Blackpink members each inside this folder for testing purposes. So here is the for looping to loop your one by one of the images. So here after that you validate and predict the image, and list index is to sort the indexes, and here is sorting the images where I get the highest accuracy with the nearest accuracy nearest to the classification here. So finally I print out the classification for the first element inside the list index array. So as you can see, this is the final output of the program. So the image, you can see that is 200 by 200, which is the correct measurement of what I scale in front. So here you can see that this is the list of the array, the list index. All of them are 0 beside except the first one. The first element is 1, means that this is selected. This element is selected as the nearest, the most accurate classification by the program. So the first element of the array is Jenny. So here is now Jenny, and this is Jenny. Yeah. So this the program get it right. And hereby is Lisa. So the third element of the array is mentioned. So the third element is Lisa. Yeah. So Lisa is printed out. Yeah. So let's get it correct again. So this is basically how my codes work and my program runs. Thank you very much.